All right, MCT4C, day 42. The lesson is 5.4, evaluating polynomial functions. Now, we'll see that today's stuff, there's not a lot new, except for we're going to lean on the graphing calculators a little bit, but we're going to start with a 3-minute review, which is a review of what we did yesterday, which was some pretty cool stuff. We were able to graph polynomial functions without help of the TI-83, and we got pretty good drawings, and that's what we're reviewing today. So here we're just asked to sketch these things. They're in factored form, so setting up my set of axes here. And what's the story? Well, I see it's 1, 2, 3. This is A is degree 3, negative leading coefficient, so it starts high and ends low. Remember, since it's degree 3, it always starts one way and ends the opposite way. In this case, because the leading coefficient is negative, it starts high and ends low like this. And then we got x-intercepts 0, -2, and 1, and they're all slash roots, right? So I'm going to put -2 over here. I don't really care about scale too much. 0 there, of course, 1 about there, and basically hook them all up. I'm not really caring too much how far I go above and below the x-axis, how high the bumps are, because now I'm going to put some scale in at the end, right? So I pick a point, and I want to pick a decent point here, maybe -1, and I put in -1 in my calculator. Oops. -1, that kind of looks weird, but x is -1 there. And this is, how did I pick -1? Well, I just picked any point. I'm picking any point so I can put some scale on my graph. And that ends up being -2. So that point right there is -1, -2. And there I've got some scale. Essentially, this right here, this calculation that we did already yesterday, this right here, is today's stuff. That's today's lesson, evaluating polynomial functions. So it's not going to be too scary. We're going to use the opportunity to learn or review some other stuff on the calculator, but it's not too scary. This next one, we got a double root there and a double root there. That's degree 4. Leading coefficient is positive. I don't see any negatives hanging around, so it starts high and ends high. And I got x-intercepts at -2 and 2. That one's a 2 and that one's a -2. And both of them are bounces. And so hopefully I can sketch this pretty quickly. -2 is over here. +2 is over there. And it starts high and ends high. So this is a bounce there, bounce there. A perfect W, and in fact this one looks like it's symmetric. This looks like an even function, maybe. And that right there would be a nice point to get. When x is 0, y is -2 squared times +2 squared is 16. So that's the point 0, 16, and I got my scale. Perfect, and we can do that fairly quickly. Again, today is evaluating some polynomial functions. And so this is what we did yesterday, right? Was graphing polynomial functions, except for what it looked like this though, right? I see it's degree 3, so it's probably 3 brackets if they're singles. If there's a bounce, there'll be a squared on one of them, and there'll only be 2 brackets. But the question is, what is this? We've got no idea how to go from here to here, so we're kind of stuck, right? We're kind of stuck right now. We don't know how to do this. So we're going to lean on our calculators to help us. The first technique is to just bash it into our scientific calculator. So essentially what we're doing is we're building a table of values here, okay? So I'm going to make a table of values over here in the corner. And, well, I just got to pick some values of x and then calculate what y is and start doing some points. Now, this will get tedious in a hurry, right? Notice that if I have x equals 0, it's not so bad because 0 cubed minus 0, and this gets 0. So this is just 4. I don't even need a calculator. But after that, you know, even when x is 1, I'm going to want to be careful on my calculator. 1 to the exponent 3 minus 1 to the exponent 2 minus 4 times 1 plus 4 equals, that's equal to 0. Okay, so when x was 1, y equals 0. And notice on your scientific calculator, you may be good at getting, like, maybe you can go up and just change that 1 to a 2 so we could get the next value. But, you know, if I were going to use the scientific calculator, I'd be here a little while. But what I'm going to do is I'm going to get started. I'm going to put those points on the graph and see what it looks like. Use a bit of a scale here. There's 1, 2, 3, -1 over here, and so on. 0, 4. I don't know how high these are going to go, so maybe I shouldn't. Maybe I'm going to make this B4 and have my first dot right there. Okay, and then this one's right here, and that's all I got so far, right? This is sad because, I mean, the 3-minute review questions, we would have been done already if we had it in this factored form, but we don't have that. So we might reach for the graphing calculators to try and help us out, and that's what we're going to do. So there's a couple ways to get this working faster. And I've noticed that I've got the steps here. I'm going to follow these steps. You can pause the video and write those down if you want to. That's up to you. Crazy. So in y equals, and you might have all sorts of crazy stuff in here, and that's all fine. But you need to type in the function. The function is x to the exponent 3 minus x squared minus 4x plus 4. And then to graph it, well, you could just press graph, but that would be relying on whatever window settings were there. A good place to start is Zoom 6 or Zoom Standard. That's a good place to start. And then you might need to switch it from there because if the line goes up too fast or too slow, you might need to switch it. So once I got my graph, then I can use some of these calc commands. So the first one I want to show you is the value command. So I press second trace to get to the calc menu, and when I hit 1, it's the value command. Now it wants me to put in a value for x, and it's going to calculate y for me. So I'm going to put in 2, and then bam, it jumps right there. When x was 2, y was 0. So I can add that to my big table of values, and I can keep doing that. Actually, this is kind of a pain. Actually, I don't use the value command very much because I'll show you why. When x is 3, y is 10. Because once I'm on the graph, once I'm the little spider on the graph, for one, as long as I'm on the graph, I hit trace and I'm moving back and forth as the spider on the graph, I can get whatever points I want. And the value function's kind of built in because all I would have to do, as long as I'm a spider on the graph, I just press 3 and press enter and it jumps right there. So that's pretty slick, right? 436, even though I can't show that on the graph, it's too big. And so that's value. It would be nice though if it just gave us the table, and it will. How we do this is second function graph. You see that's yellow, and it's got the table there. Second graph gives me the table. And now notice mine's got all these values from whenever we were using this last. It might have been from the other course, I don't know. But this isn't what I want. So I need to go back, and that's what this says, go back and set up the table. If I go second function window, that gets to the table settings. And notice that this is a little bit goofed up. If I wanted to, I could start my table wherever I'd like, and then it'll automatically generate it. And this is the little change in table is how much the table is going up for. If I press auto, it'll automatically generate the table for me. So I'm going to press second table, and then it starts at -3 and goes up by 1. See, now that's slick. What was that, 20? -20. And then I see my -2 was a 0. And now, now I've got enough information that I can graph this. -1 is 6, and so on. All right, so I'm going to graph these. 2 was 0, 3 was 10, which I think I can fit there on. 3, 2, 4, 6, 8, 10, is that 20? 4, 36 I can't reach on. -3, -20 I can't fit on, but -2, 0, that's pretty good. And -1, 6. 2, 4, 6. Good. And then, oh, -1, +6. Whoops. -1, +6, 2, 4, 6. And then I kind of just got to do a smooth curve through all of these now that I got the points. And that kind of looks like the graph that I had, right? Sure it does. Sure it does. Which is great. Now, I'm going to come back and talk about this in a second, but wouldn't it be nice if we could find out the minimum and maximum values here? Because it kind of looks like it's at 1.5. It kind of looks like it's almost at -1 something. But is there a way that the calculator will give this to us? And there is. Just like I can use the calc menu to find values, and I can find zeros. I can also find minimum and maximum values. So here, second function calc, second function trace, which gives me the calc menu. I can go minimum, and then I just follow the on-screen instructions. It wants me to find the left bound. Where do I want to be? Where's the minimum I want to find? Because there could be more than one. Well, I want to go to the left of it, and then to the right of it. So I press enter, and then it sort of puts a marker where I've went. And I want to go to the right of it, and I can have a big wide margin. Go to the right of it, and then go into the middle of it. And I want to get pretty close for my guess. It wants a guess. And then it'll actually give me the minimum. The minimum is at 1.5. So the minimum is at 1.53 and -0.88. Well, that's that point right there. We thought it was pretty close to 1.5, but that point right there is 1.53, -0.88, and that's the relative minimum. It'd be nice to find that point right there, and I can using the maximum calculation. So second function trace gives me the calc menu, maximum. Now notice I can scroll back, but if I just want to type in what the left bound is, and I see it's around -1, but if I put in -2, it'll put a marker at -2, and then I can, be safe. If I could scroll, but I'm just going to type in 1 because I can see at x equals 1, that'll include my maximum, and then I can scroll towards my guess, press enter, and then I get the maximum is -0.87 and 6.06, something like that. 6.06. And now we know just about all there is to know about this function. Now, I'm going to pick the rest up in just a second, but in part two. But I want to mention something here. Those are pretty good things to know, right? And in fact, because we know the zeros, we actually know what this is in factored form. Because that's a point, we know that that must be a bracket. It's a slash root too. Because that's a point, that must be a bracket. And because that's a point, that must be a bracket. That must be this expanded or factored. But the question is how do we do that without a calculator? Well, that's coming. Okay, not today, a couple of days, and this is actually quite a procedure to be able to do this. All right, I'm going to pick up the last two examples in part two, which should be a shorter part.